So my name is Doron Markel, and I work for the Water Authority, and I'm in charge of the monitoring and management systems of Lake Kinneret and its watershed. And I would like to speak a few minutes about the situation, the water situation in Israel, and particularly in the north. And I'll try. Let's see if our technology works. I'll try to show you a short presentation. Let's see. Yeah. Now it should work. Yeah. Okay. I hope everybody sees the presentation. Gary, is it working?
Beautiful.
All right. So preserving Lake Kinneret, the Sea of Galilee, as a strategic water resource in a changing climate. And I'll start in saying that we are facing a climate change. And I will try to prove that.
Doron, just one comment. Since there are people who do not see the presentation, just when you review them, say what is it in the slide that you're speaking about.
Okay, I thought that everybody can watch the presentation. Okay, but yeah, so here in this slide you see the map of Israel with different major water resources of Israel: the Kinneret Basin, the coastal aquifers, the mountain aquifer, and the numbers are the annual replenishment in million cubic meters per year, and you see the total annual replenishment was used to summarize until 1980 to about 1,500 million cubic meters per year, which is about 1.2 million acre-feet per year. However, if you average the numbers in the last 20 years, you see the numbers are much smaller. And that's because we have much less rain. See, in the Kinneret Basin, the number decreased in 200 million cubic meters per year, every year. And also in the coastal aquifer and mountain aquifer, but the worst area and the scarcity is in the Kinneret Basin. Now, I call the Lake Kinneret, but I understand you all know I mean the Sea of Galilee. So the climate change is here. And in this graph, I show the net inflow into Lake Kinneret from 1975 to 2017 and see the significant decreasing trend of net inflow. In numbers, the inflow has decreased in about 200 million cubic meters per year. And we know also that most of this 200 has to do with decrease in precipitation. And look what happened in the last 4 years. The last 4 years, we have a terrible drought. The last 4 successive years, the inflow to Lake Kinneret was the lowest in the history, at least in the measured history, but I think that for hundreds of years, the lake did not see such low inflow. And you also might know that Israel has constructed, in the last decade or so, Israel has constructed 5 huge desalination plants on the shore of the Mediterranean, producing in total about 580 million cubic meters per year. And that's great. That's fantastic, and gives a very good answer for water scarcity in the central of Israel. However, none of these desalination plants can discharge water today towards northeast of Israel and to the basin of the Sea of Galilee. None of them. Now, people ask us, why? Why should Israel preserve Lake Kinneret as a strategic water resource in the era of desalination and climate change? Why don't you just announce that it's not a water resource anymore? It can be for tourism or so, and use the desalination plants for producing water. Why? And first of all, we have dealt with this question and came to a very clear, sharp answer. Lake Kinneret must and will continue to serve as a strategic water resource for Israel. Desalination will enable flexible water supply. And I'll give you two very good reasons for that. One is the fact that desalination plants are very vulnerable. I don't want to give any idea to anybody, but you can harm a desalination plant. And we don't want to be in a situation while one of our 5 desalination plants fail, and we fail to supply water to one of our cities, let's say the city of Haifa, would be without water for, let's say, a week. It's something that we cannot stand, and we cannot let. And Lake Kinneret is the only natural water resource that by pushing one button, you can flush discharge water through the national water carrier to almost all of Israel. That's one very good reason to preserve the lake as a water resource, as a strategic water resource, as a backup to the desalination system. The other reason has to do with the agreements with the Kingdom of Jordan. Since the peace treaty back in 1994, we supply to the Jordanians 50 million cubic meters per year, every year. And we should stand, and it's good strategically for Israel to stand in this obligation. And that's a second very good reason to preserve the lake as a strategic water resource. But I said, we're facing a climatic change. And what about the future? And when we look to the future with models, our climatologists use models to look towards the future. They claim that the situation will go, or the net inflow will go ever decrease, and the net inflow will be in 2050 somewhat around 200 million cubic meters per year. It means that our deficit, which is today about 200, will be about 300 by the year 2050. So we must do we must take operational steps in order to be prepared to 2050. But before that, let's look at the consequences. What are the consequences of the drought? First of all, the water level of Lake Kinneret. And you can see that the water level decreased below what we call the lower red line. It's a water level which is, according to our experts, it is very bad to be in that water level. And we've been to such levels back during the droughts of 2001, during the drought of 2008, 9, and 10, and unfortunately, we are at the same very low water level right now. That's one consequence. The second is salinity, and Lake Kinneret has saline springs around it, which causes its salinity to be mid-salinity with a chloride concentration of about something between 200 to 300 milligrams per liter chloride. And to be above 300 milligrams per liter chloride, it's very bad for water supply. And unfortunately, due to the drought and due to the fact that there is not enough freshwater exchange in the lake, we have crossed, this year we have crossed the 300 milligrams per liter concentration of chloride for the first time since 1968. And that's very bad. And if you look to the future about salinity, and we use models also for that, you can see here different lines, different colors for different lines of different water inflow. If water inflow, net inflow will be 300, the blue line, we're fine. Salinity will decrease, situation will be fine. However, if it will be less, 250 in green, 200 in yellow, and 150 in red, we are in a very bad situation regarding salinity of the lake. Second water quality issue is the cyanobacteria blooms. And like every lake, we have algae. And like most of the western world lakes, lately we have cyanobacteria blooms. And I'm showing picture of bloom of February 2016 of Lake Kinneret, but I have this picture from Lake Erie back in August 2014 in Lake Erie, US and Canada. There was a severe bloom of cyanobacteria and a problem of water supply to the city of Toledo, Ohio. And we still far away from situation like in Lake Erie, but that's something we should consider, and we want to take steps in order to prevent this situation. Again, if you look to the future with models, if there are not going to be enough water exchange in the lake, we're going to have more and more cyanobacteria blooms. Now, what can be done regarding salinity? We already taking steps of removing salt, removing saline springs by our bypass saline conveyance, and just lately we operated what the picture in the left you can see here, the submarine spring, which was capped by a spatial capture, was connected to the bypass conveyance, and right now all this saline water from the cap is discharged to the saline bypass conveyance and removes from Lake Kinneret. Regarding the cyanobacteria, the key is to have a very strict lake watershed management, and that's what we have: fishery management, coastal management, watershed management, sewage pollution prevention, like sewage. Our policy is zero sewage leakage towards the lakes, zero, and we stand in that policy. Removal of any fecal source, and treating also diffuse pollution, like in our very nice wetland, the Hula wetland. But finally, we are at the point of understanding that all the steps we've done, and we try to do even more, won't be enough. And we are now think about a plan to enhance the water amounts in the watershed. First of all, and that's already has been done, limiting agricultural consumption. Second, enhancing our artesian wells. That's something that has been done during the last 7, 8 years, and we have more planned artesian wells, like Shamir wells, probably you know, were funded by the JNF, and they do very good job. They produce a lot of water, which is used for agriculture. And once agriculture use the artesian wells water, it releases the natural water to flow downstream towards Lake Kinneret. But finally, we speak about we think and plan, the big plan, the mega plan to import outsourced water to the Kinneret Basin, meaning from the national water system. And that means to reverse the direction of the national water carrier. I'm not laughing. I'm not laughing. The national water carrier was constructed and operated back in 1964. Okay? More than 50 years ago. And right now, we think about a program to reverse its direction and bring water from the desalination plant through the national water carrier towards Lake Kinneret. That's the traditional direction. But the new direction, towards Lake Kinneret and the basin, I'll show it back on the map. Here you see, with two possibilities. One, to fill up the lake directly, and one, to bring water to the basin. How the farmers use this outsourced water and let the natural water to flow downstream towards Lake Kinneret. And by that, I'm done.